Today is 12th of January. We
Have I
are
joined it?
we are doing LinkedList DeleteNode problem analyzing.
Time, but
Please share it.
time. It's disabled. I can't share my screen. No. Can you see?
No, you should share your screen. Still unable.
It's because I'm a visitor.
Yeah, good.
No. Go.
All right.
Should probably minimize anything which is private. Save.
Yeah, what I actually first did was hopper.next equals to hopper.next.next, right?
Yes, which is what you're not supposed to do. Okay. There we go. Let's go. Okay. Have you started?
Yeah, can you explain this part?
So to keep it simple, what you're essentially doing is first of all, you check whether the position is in position 0. If it's in position 0, just return, okay, so list LL list next. Simple. Now you go to store your hopper, which is essentially your the object which keeps jumping towards the next position. You can just imagine like on the right side. It's essentially for the object, it just keeps moving forwards, right? So this is like just boom. Now only those objects are in the scope, and etc. It's quite simple. And now, because you only need to know the position of the object before the object you want to delete, because then you can just set object to the position, the next to the position after the object which has been deleted, essentially just skipping the object itself. So just like next. So instead of pointing here, just pointing towards, like copying this line and then just pointing towards this. And the objects then in here just gets deleted by the garbage collector from Java, which is quite simple and easy solution for this. And that's essentially it.
Well, why? But I also saw someone solve it by like hopper.next equals to hopper.next.next.
Yes, I'm also doing it here. It's just that the position you did the next was in the wrong position. You were trying to do it in the for loop.
If what happened if I do it in here?
Well, if you do it in there, what it's essentially going to do is, let's just shortly visualize it as a box. What you're essentially going to do, well, actually just visualize the box, yes. So what you're going to do is like, as I said before, if you do next, it's just going to do like this, because you're like essentially positioning to this object, right? If you do next, it's going to go this, and then you're suddenly there. So you're going to skip the object over here. You're not even going to look at it. And so, let's just say if essentially you're just going to do it for every single object. You're just going to skip and then boom. And yeah, it's not good. It's not the intended purpose behind it. So if, for example, you're trying to lead position 1, it would be now here, and that would be wrong. So yeah, don't do that.
I also do. So sometimes hopper.next equals to hopper.
Hopper.next, well, you actually have it in here technically. So what it does, hopper.next equals to hopper. Well, you're inserting an entry before at the start, right? Because if you say hopper, dot next equals to hopper, you're essentially just inserting in your entry. Right?
Inserting entry.
Yes, of course, hopper dot next. If hopper dot next is hopper, that means that
Then that's
where are you doing that? Hopper dot next.
is it nothing?
No, the object points towards itself. Because like if hopper dot next points towards hopper dot next, sorry, hopper points towards hopper points towards hopper dot next points towards hopper. It's recursive. It keeps pointing towards itself infinitely.
At first you use two hopper. Can you also explain it?
So before I used two hopper, you mean the hopper and the previous one?
Yeah.
Sometimes you want to have a previous one. For example, let's just say I'm searching for a certain value. Like I'm searching a value I want to delete out of my linked list. And so what I can do is I can, as soon as I meet the value in the linked list, like for example, I'm searching to delete 4, I now have the previous value. And then I can just say previous hopper equals next. And I just skip the one I'm trying to delete. Should I implement this as like an example code to show you how that would work? So what you can do is you can just have that prev. Let's shortly set this to
Diff prev is different prev. This is node.
So this is a node, but it's the previous one. So what you can do is now, for example, let's just say I want to go to shortly say while what we can do is we can do hopper dot next not equals to null. So this is going to essentially run till the end of the actual array, sorry, the linked list. And so what we can do now is we can just say, okay, so if a second, what we can do now is or actually,
maybe we can use counter to check.
no, what I just I'm thinking right now. If hopper dot data equals to let's just say 4. Let's just say we're trying to figure out whether that. And now what we can do is now we have hopper data, okay? So what we're going to do now is we're going to just say, okay, so hopper, just a bit tired, sorry about that, is equals to hopper dot next, so that we're going to go to the next entry. And what we're going to do is now we're going to do as hopper equals to, sorry, previous is equals to hopper. So what we've now done is now we know the previous hopper and we now know the next hopper. So the one we're going to jump to now.
Hopper just jump to next one and previous goes to
yes,
hopper.
and yes, because now we're saying, okay, so and now that we've done this, essentially we're like, okay, so this one and this is the next one. And now we're going to check, is this 4, right?
Why are you checking it? Is it 4?
Because I want to delete this one technically.
Data.
Yes.
You're checking data.
I'm checking data, but I want to delete
we don't know it is 4.
No, it's just an example. I just said I want to delete 4.
Okay.
This is just an example. And now what I can do, because you were asking why do the hopper previous one. And so what I can do now is I can just say, okay, so it's now 4. So hopper dot it's going to delete anyone which is 4 at the moment right now. Hopper dot prev is now equals to prev next will now be pointing towards hopper dot next, right? Because this is the one which follows on the one we're going to delete now. And now you've just deleted the 4 from your linked list. And that's why you want to sometimes use the previous hopper in these kind of situations.
I'm confusing with this equal sign.
Hmm?
Is this like meaning of assigning or is it just pointing right now?
Which one?
The equal sign.
And where?
The equal sign here.
So what it's essentially doing is it's assigning the next of the previous one to be the hopper of the next, because the previous next is essentially where it's pointing towards, right? And right now it's pointing towards this one. Let's just say this is the 4. And what I want to do is I know this one, the next of this is this one, right? And so instead of storing the next this one, I'm just going to say, okay, so I'm just going to store this one. Boom. And now I've used
Then I can think it's actually moving or it's just change it to this one.
Yes, I'm just moving the pointer towards the other one, essentially.
But this is equal sign. It should become this box itself, not just pointing it.
Well, the next is essentially the next is essentially the object, but it's essentially just point towards the object, essentially. Like it's a link towards the next object. Well, that's what it is. That's how I would imagine it. Does it make sense?
Then equal sign is actually pointer.
Technically, if you look at how Java deals, every object, it's technically a memory location, right? So it's the same reason why when you do, for example, a string, let's just say you statically create a string. You can try this one. You know how normally when you're doing string compare operations, you have to use the dot equals function, right? If you statically generate a string at runtime, so like at the start, so just like string test this yes and string test 2, and you do that like for example in the main, and you do this. If you do if test equals test 2, would this return true? Would this return true from what you know from Java?
It would not return true, right?
If it's defined in the main and it's static, it will return true for one reason and one reason alone. Because Java compares memory of an object.
Memory.
So like the address of an object. And because Java optimizes strings, it's one of the few exceptions why strings in Java are not the same as normal objects. It will actually store it in the same memory location. So it's both of them are made. If it's the same string, they're going to both point towards the same object in. So it's like, yeah, so essentially it's a memory location. But yeah, that's essentially it.
And should I think equal sign is pointer?
No, it's an assignment operation, but for the linked list, it makes it simpler to understand the concept of linked lists for me personally. It's just a
You
personal
just think it as
it's just pointing towards the next object in the linked list.
Next.
It's like, oh yeah, essentially imagine of it like a book, and each page is pointing towards the next page in the list of pages.
That's how you think in linked list.
Yes, that's how I think about linked lists. But that's just my personal preference. There's other analogies you can use to understand it.
Thank you very much.
You're welcome.